Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ASU Actuary. Here's a problem for today for exam P. On any given day, a certain machine has either no malfunctions or exactly one malfunction. The probability of malfunction on any given day is 0.4. Machine malfunctions on different days are mutually independent. Calculate the probability that the machine has its third malfunction on the fifth day, given that the machine has not had three malfunctions in the first 3 days. So one thing that you should notice when you look at this immediately is that every day is a Bernoulli trial. You either have no malfunctions or one malfunction. And then this is you given the probability of success or failure depending on how you phrase it, and then you are asked to count the number of malfunctions in the number of trials, and the probability distribution that counts how many times you have to fail until you succeed the prescribed time is called the negative binomial distribution. If you count only until the first success, then that's geometric distribution. But if you count until a prescribed number of successes and you count the failures, then that's a standard definition of negative binomial distribution. Note that if the machine has its third malfunction on the fifth day, then the machine has not had three malfunctions in the first 3 days. And that means that the event that the machine has not had three malfunctions in the first 3 days is implied by the event of having the third malfunction on the fifth day. So having a third malfunction on the fifth day is a subset or sub-event of the event of having no three malfunctions in the first 3 days. Okay, because having third malfunction on the fifth day implies that there were no three malfunctions in the first 3 days. Whatever the number of malfunctions in the first 3 days was, it was not 3. That's the point. And that means that if you take the probability of third malfunction on the fifth day, given that no three malfunctions in the first 3 days, then that's the probability of intersection of the two. But that's the intersection of the two is just the event that the machine has a third malfunction on the fifth day, because that's a subset of the second one. So then the conditional probability distribution applied here gives us that this is equal to a probability that machine has third malfunction on the fifth day divided by probability that the machine has not had three malfunctions in the first 3 days. So now consider the negative binomial random variable n that counts the number of days without malfunction, which we consider a failure, and this failure happens with probability 0.6 until the third day with malfunction happens, until the third success, and the success has probability of 0.4. Then the probability in the numerator of that expression that we had there is the probability that n is equal to 2. For a negative binomial distribution, that's 5 minus 1, choose 2, so really 4 choose 2, times 0.4 cubed, because 3 successes, times 0.6 squared, because the number of failures until the third success is 2. The total number of trials is 5. The reason why we, by the way, do 5 minus 1 there in 5 minus 1 choose 2 is because the last attempt has to be a success, so there's no choice about that. That's why we only pick 2 places for the first 2 successes, which is equivalent to picking 2 places for 2 failures, either way, among the first 4. The 5th one has to be a success because we achieve the 3rd success on the 5th attempt. And then we calculate this to be 0.13824. And the probability in the denominator is 1 minus the probability at n is 0. Because when n is 0, that means that you had success, 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 no failures, and then you get 3 successes. And that's 1 minus 3, 3 minus 1, choose 0. So, and then multiply by 0.4 cubed because 3 successes times 0.6 to 0 because 0 failures. And this 3 minus 1 choose 0 is the number of ways to pick 0 successes among the first 2 trials. Of course, there's only one way to do this. So this ends up being 1 minus 0.4 cubed, and that's 0.936. And the probability set is the ratio of the two, 0.13824 divided by 0.936. That's approximately 0.1476923, which is answer C. Please remember this is copyrighted material. The problem itself originates from Society of Actuaries, belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.